All right, welcome to podcast episode 1. Your turn. Look at that. There's the title card. So, the reason we're doing this, Ashutosh, is with the executive meetings per week, we're already sort of doing this like review of current events throughout the week,
Mm-hmm.
and we're this is the newspaper, as you can see.
Yeah.
You're working on this page?
Yeah. The second one in that turnkey page,
Yeah.
the second one.
Is this one done then?
No, I'm wrapping up
Oh,
on building the skeleton, basically dividing the page into multiple sections, and then I'll fill out the content and then
well,
style it.
anyway, here's your turn. You can see, listen to podcasts. So we need freaking material.
Mm-hmm.
And we already talk about current events and whatnot. So it'd be advantageous for us to just record that as a separate podcast for the most part. And so I'll actually set up a legitimate time to do that. We're going to have a blog section always. This is going to be very reminiscent of IBM's Think. Think is their slogan, and when you go here, you get a bunch of, you're showered with articles, and some of them are videos down here, and we want to make the same thing come across. So that's why we have our always page, which right now is just going to be a very simple UI. Always just a bunch of stuff. These are just what all the cards will look like, and they'll either say read or watch, and we'll go over stuff like that.
Yeah, this is just dummy data for now.
We'll have a contact page and everything. Yeah, are you having any trouble on this?
No, it's just a lot of content and it's a long page, so there's a lot of styling to be done, and we need to divide the page into the right sections because, as Maxim explained yesterday, this is going to be separate chunks inside a page.
Yes, and don't forget that, you have this over here. Don't forget that it comes from over here, right? Like you can steal these components. I purposefully made this very simple so that even though there's a lot of pages, they all basically copy paste most of their content so that you don't have to do too many new things. Like
And
this is just a resized card of this guy over here. I made this easy. This isn't scrollable. These just collapse into a smaller space. These just stack on top of each other. These just extend with some kind of shape. And if you're having trouble on something aesthetic like what is this, like fade in
yeah,
the
the transition.
background,
It's a
don't fret about it and spend all your time on it.
no,
Just
no. That's
move on to more skeleton stuff, and then Maxim can help with some of the weird things.
Mhm.
But so these are 3 interesting articles that I definitely want to get into. This company, Typhoon, is a Russian company that's doing something quite similar to what we're doing, but they're so under the radar.
right.
It's just not, when your website is so poorly explained. Like the first page I'm hit with is software, autocode Triton, experimental development of IDE for Triton processor. Okay.
It's a carousel, so it just keeps
It's
on
like,
going to.
I don't know what Triton means. So I don't know what an IDE for a Triton microprocessor is. Like they didn't tell me. I don't even know what they do. All I know is that software is something. Like
Yeah. If
they
you go to the first one, I think it says Triton is
it says Typhoon.
okay. Wait, this is Typhoon is 7-bit.
It's just a mess, right? I purposely wanted to make sure that we're gonna build this website in a way where we slam you with knowledge. You get to the homepage. Oh, what is this company? Turned up. We design advanced semiconductors. No question. We design advanced semiconductors.
Straightforward.
Like that is it. We just go boom. Initially, this was here, the future of AI, a nice little tagline, but it's like screw that. We're a newer company, and it can get vague in deep tech. So what we're gonna do is we're just going to immediately say, hey, we design semiconductors that are better than the ones that we currently have. That's it. We're not going to start saying ternary 01 la di da, like confuse
Yeah.
everybody. And then you can discover Tern, which is going to shoot you over to the about page, or you can watch a demo, which will go to our turnkey demo video, which has to be better. So, this is just really important to make life easier. So the future of AI is built on Tern. We show you we got some noise going on, little blurb. And we show you we're going into the actual microprocessor, and it's just very nice and neat. Same with the turnkey page is really important. So this is actually tricky to explain because it does come with a lot of complexity. So we go like, all right, tagline. Tagline so you know it's a product. Like, boom, turnkey, try it free, watch the demo. So you know it's a product, you know it's something you're supposed to use or buy. And we're like, all right, it's the first ternary software stack, which is the best way to formulate it. Sandbox environment's confusing. It's supposed to be an IDE, but it's more than an IDE because you have an assembler down there too and an assembly language. So you can't just call it an IDE. This will have an IDE in it. So then a little blurb. Then you have an example of what it looks like, which honestly could use a little bit more light in the back. And then you explain it a little more, talk about G, then you give them a link to actually use, check out the handbook. This is a link to the demo
So
or something.
I have a question here. When you talk about the ID, do you mean the page wherein we're putting in the G code and then we get the
No,
terminal?
IDE is something else. IDE
So,
is like
yeah,
a VS Code.
yeah, that would have been playground. Yeah, just wanted to clarify.
Yeah, this is just a playground, and IDE will be a part of that eventually. But we
Yeah.
don't need an IDE right now. We need one before we use hardware. And then, just little blurbs. But this gets the point across
Do
for
we really
the
need to
product.
build a separate IDE? Because we could just use VS Code and develop, packages to support G.
It's in the works. There's a lot of we definitely want to take a balance between what's necessary and what is and being frugal. We don't want to reinvent the wheel. You're right, but I don't know. The only thought that's been put into the IDE is that we need to put more thought into it. So
Okay. Yeah.
we're,
Work in
we're okay
progress.
for now. Yes, absolutely. And same with we had what point did we have brought up? The fact that we need an OS, right, for this eventual thing. And a software developer, very knowledgeable software developer who asks great questions, Jida, was in the office yesterday, and she was sitting down at the desk with me, just asking a million questions, right, about everything. And she asked great questions. One of them was about the OS and what people do. That, like, it's great to have the website and have people question all these things. But when software engineers who get closer, who we want to work with us, ask questions about it, they go too deep. They're like, well, how are you going to do this? You're going to have to redesign all this. It's like, well,
Yeah.
wait, what do we need to do? At the end of the day, we need a system that communicates with a ternary a transistor that is able to output three different signals, or at least be read in three different signals. And we need it to run code on a piece of hardware. Like, that's what needs to happen in general for us to do something that's never been done before. Okay, that's a good start. But when people say, oh, but you need to know it, we could write, like, remember how DDoS used to just be like, you're just typing on a terminal? That's all we need. All we need is to be able to like type a little bit of words like access a file. Boom. Okay. So talk about minimum OS. We need the most minimum basic OS in the world just to show that this hardware talks to software and works properly.
Yeah, bare metal.
Another question that I was struggling to answer last night that I realized I don't really need to answer as much is, oh, well, what's the benefit of the software of like G? Like, what's the benefit? I'm like, oh, well, you can branch in three ways, this and that. And it was like, yeah, but that's not enough of a, like, why not just use, it's like, really, you could keep all programming languages mostly the same. Because the main benefit is the fact that they compile down to our assembly code, which assembles down to the machine code, which which allows for much higher density storage, which allows for uh, much much better, much more efficient communication, just because of the three states and everything. So that's a story that we have to tell in a different way. Is Russians typhoon? Have you ever heard of Harum's law,
Not
Ashutosh?
really.
I feel like you would have, because this honestly really lines up with
Wait, let me see.
what you usually find as a concern. And when this says users, this means software engineers. So it's essentially saying
Yeah.
when you have enough engineers on a project, any change you make is going to trip somebody else up.
Yeah,
So
this is.
if
I mean, I
Ashutosh,
never really knew there was a name for this law, but yeah.
yeah, yeah, Harum's law. So I'd love to make a collection of this stuff and form it into our genuine or genuine general uh our general documentation for the company, so that people know about like what Hurum's law is, and when you know the name, it's easier to avoid it, kind of thing. What about the law of Demeter? You ever heard this?
The names are unfamiliar, but if I look at the
Uh,
content,
okay. Yeah, don't create method chains. So so it two method chains that are too deep, using too many method chains creates too much coupling and just is extremely inefficient code.
yeah.
That's like the law of Demeter. Is wish they had like a link somewhere about it. But yeah, so that's another law I'd like to tick into. This was an interesting thing that was said at CES. NVIDIA TSMC develop advanced silicon photonic chip prototype, says report. This is honestly a rumor. They didn't announce anything. But what? How do you feel about photonic computing?
Well, it won't be protonic. We don't really move around protons. We work with electrons.
Photons, not protons.
Photons. Oh, okay. Photons.
Photonic chip.
Eh, I see. Photonic here in this sense would probably be since photons are what activates and energizes electrons to move to higher orbits. So I see that working out because that is what excites particular electrons in atoms. There's an excitation state, and and when photons uh, collide with these particles, they energize those electrons. So that's, yeah, a photovoltaic cell works in the same manner. That's how you get solar panels to work.
So,
I can see it happening in a chip.
well, the interesting thing is they keep the entire CMOS wafer the same, and all they do is customize the layer on top of that. But I still feel like this is what I feel like photonic. This this thing right here, all the way down here, is where the bottlenecks are being incurred. And so when you build this on top, you know what you're doing? This is what you're building. This is what you're building.
Look at how hot that exhaust is. It's about to explode by the looks of it.
That's what I feel like you're building when you build a photonic chip. You're really just increasing how fast you're going to uh, exceed the limitation. It gets you to reach bottlenecks faster. That's it. But a photonic chip is going to be even more bottlenecked than they are right now. They're already bottlenecked. Like it wouldn't even be able to communicate that much information. So
You know what they say, right? You can have it fast, you can have it cheap, you can have it good. And out of all these three, you can only pick two.
yeah. Well, what if you had three
That's
options? What if you had three states to choose from?
Yeah, but then that's how the industry has been doing it. They pick fast and they pick cheap, which is why it's not always good.
Yeah. Well, we're thinking ahead for the future, and that requires um Room's lawn from. Oh yeah, this is so Lori Wired, love her. I think she's one of the best software engineers in the world. Harum's law comes where future versions exactly replicate an undesirable feature of a previous version. So that's another thing. Is
Yeah, we've seen it in practice at Tern.
this is a great example. The CPU no longer overheats when you hold down spacebar. This update broke my workflow. My control free is hard to reach, so I hold spacebar instead, and I configure Emacs to interpret rapid temperature rise as control. That's horrifying. Look, my setup works for me. Just add an option to re-enable spacebar heating. So every change breaks someone's workflow
Yeah.
because somebody was using that as a thing. So it's very it's very eye-opening, and I love this law because it's very uh what's the opposite? It's selfless. It's a very selfless law that reminds you that you work with a team. So I really like things that remind you that you work with a team. And look at this. uh AI tricks up the company sleeve. Well, I guess it's not called photonic. Wait, where is it? This is supposed to be about photonic chips. Why was this? Why was this in here?
Yeah, I don't think AI tricks is. I don't see how it's.
The compute power available to AI companies today.
Light chips. Yeah, yeah. It says light chips.
This says the new light chips are in the works. That could make it more cost effective to run the models. I I disagree. I really feel like we are putting a rocket on the back of a bicycle instead of making a car.
This is why back in the day when people used to work mostly with C++, they would try to optimize the code, and in that process they would figure out crazy things about how stuff works. I mean, I know I so there was this game that was being developed, Quake 3, and to perform some distance calculations they needed to uh, perform this mathematical operation, the inverse square root, and to do that they figured out bitwise operations that make it faster.
And yeah, I assume they also found out why that's the case.
There was this weird number that they would multiply with, and then they would do binary rotations, uh, and it just works.
I don't know how to fix this. I've been getting this error with so many things on my computer. This thing pops up like instructions memory cannot be read for all different things, settings.x, runtime.broker, all this random stuff. And like no Windows applications work. If I do this, no Windows applications work, and I'm really confused why my computer isn't working. Right now, this happens every time I open my Photos application.
Yeah, something's been corrupted.
Not worth looking into. I'm able to survive without it, so until it becomes a problem, I'm gonna keep going. Hey, that was interesting what you said about wristbands when we were talking about tech. And
The next thing in wearables.
the next wearable, yeah, because when we went to that panel, I mean, Meta Glasses is a great example of it, but it seems like that Mina guy was also felt that the wristband was the next thing.
Yeah.
I disagree. I feel like it's going to be glasses, and I feel like instead of the wristband, we should be using eye movements to
So
you should be able to detect when and there should be some sort of measurement you can take that identifies that a person's neurons are thinking about clicking,
yeah,
like
so
activate that, like I want to enter that button kind of thing. So
that will be when Neuralink is a thing. That'll come up when Neuralink is a thing.
yeah, that's deeper though. I feel like what's first going to work is actually detecting the micro movements of the eye itself. Like I imagine when you look at something and you focus at it to the point where you want to click it. Like if you focus at anything on your screen and decide like it's a button and you want to click it, or you don't know it's a button and you want to click it in general, nothing will happen if you click it. Maybe your pupil dilates like slightly in this way or something.
So
So
think about this: how the when you wear these glasses, even if you were like a meta quest or whatever, and think about the distance that actually exists between your pupil, you actually your cornea, the topmost layer of your cornea, and the glass itself. Now within that distance you need to be able to transmit image transmit light from outside, let the environment light come in for mixed reality, then also have its own display come up and detect the eye movements, have some sort of camera in that. So it's going to be a long way before we figure out how we can manage all of that and make all of it fit into this small form factor.
Well, it's not going to happen if we're not using a new if we don't use advanced technology.
Yeah, of course.
And I mean
So it needs to
that's
do at least three things.
that's ternary as far as I'm concerned. It's a ternary transistor. Make a ternary transistor,
You
throw
know,
it together on CMOS silicon on the same machines that we use today. In fact, use the same transistors. Use almost the exact same transistors. You can almost use the same transistor. Just read it slightly a little different.
yeah,
Like it doesn't seem that I feel like from a regular JFET or a regular MOSFET or a modified MOSFET, both still being able to be built on current machines. Like that's I want us to submit a few patents that throw out a couple of ideas of transistors, or really just one because it costs too much money, and just a provisional patent too, because even a couple $100 is tough. So do a provisional patent and of just an idea, but then I'd want to talk really closely with manufacturers like Intel and and global foundries and ask, hey, this is one, like, what is the important part? What design? Because this is IP that they wouldn't want to just, that's not out there willy nilly. And we would say, how do you make your JFETs? Because if we know how you make them, we'll make sure that we make our ternary transistor in a way where when you build it, you can still follow your same cookie cutter uh, recipe to build them so that it's the cheapest possible way. And that's huge. Like it's not about all this reinventing the wheel. It's about like business acumen is about how do you get it to market, and you get it to market by making it work in by you disrupt the market with your product, but you enter through a channel that you're able to enter through. Oh my
yeah.
gosh, if you don't do that, like it's the same.
It's going to
It's
be it's going to be complicated because you need to figure out, hey, do I does Tern give them the license to manufacture on their end, or do we get license from them and their specifications? I mean,
no, we're not going to manufacture it. That would be like doing that with Arch. That would be
so
like
if
we're
you hand
doing
out if you
we're
give out
doing this. We're doing this is the business model we're doing. What ARM does. So you know who ARM is?
yeah, yeah,
ARM. We're going to do what they do. And you look at their architecture family, what do? ARM Holdings develops, so blah blah blah, is it's a family of risk instruction set architectures for computer processors. ARM Holdings develops the ISAs and licenses them to other companies who build the physical devices that use the instruction set.
yeah.
It
So
also designs and licenses cores that implement these ISAs. So we can sell just instruction set architecture information to Intel and say, "Hey, good luck, go build a chip with it." Or we could design an entire core and say, "Here, manufacture this. We already built the whole thing."
the thing with this is we don't just need to redefine how the processor works, but also how other components work in tangent with the processor.
All you need is a MOBO and memory
No, you still need to. If we are working on ternary, if we are making use
and
of three
power.
states, we might as well make the best out of it and just revamp everything, even the buses that are on the chip, are on the board to communicate across components.
Yes, the motherboard, the memory, the power supply, and the microprocessor all need to be unique.
Not just
You
the
don't,
microprocessor, also a couple of microcontrollers. The ones that make your keyboard run, stuff that makes your mouse run, so on and so forth.
okay, so you go through all
That's all.
those and the necessary peripherals. So all in all, what you would need is peripherals, motherboard, memory, power, chip.
Yeah,
The
and
thing is, right now we're already starting to use PAM3 and we're using ternary signals, but what we're not, and that comes with when you're able to. It all comes down to, are you able to manufacture the transistor? That's
yeah,
it. Once you're able to manufacture the transistor, then you're able to build all of these things.
yeah,
So like we would need two partnerships at the very least. We would need a partnership with we probably just need a partnership with like Intel
TSMC.
and Micron would be probably the best.
I would think
Micron,
TSMC, because they will actually be fabricating.
TSMC? No,
Yeah.
not no. They have to be American companies.
Okay, yeah.
Intel can manufacture. Global Foundries can manufacture.
Um,
Just not as much.
yeah.
But we don't need a lot. But like a
Also,
Micron could design the boards and the memory, and you could have some other. You could just make a very crude power supply. I mean, it's easy. It's harder to make a CPU than a power supply. So you just make your own power supply real quick, and you could probably make very rudimentary peripherals as well. Just make a build a monitor real quick, or just outsource that real quick. Be like, hey, make sure it communicates with this board. Make sure it uses these wires, and keyboard, mouse. You're ready to go. We
yeah.
don't even need a mouse. All you need is a keyboard.
Also, at least a Wi-Fi card.
No,
Think
no
about it.
internet. No internet. What are you?
Okay.
What machine are you going to talk to? You're the first ternary machine in existence. Why would you need the internet? All we need is a terminal that shows that software can make a transistor that has three states do its thing, right? You got to think even more simplistic. What
Yeah,
are we doing that's never been done before? And it's that.
yeah. You need some way to apply patches, right? If you mess up the software, how do you apply patches to the software?
What do you mean? You apply it to that specific machine, that exact machine. There's only one machine that you're building.
Yeah, but then still, you need to. Do you just take it all apart? Do you just wipe everything, wipe the memory, wipe the RAM, and then load up your software again? You need a way for your software to come onto the machine, to be transferred onto the machine.
Yeah, you place it into the memory cells. What do you mean?
No, so when you have updates, when you have additional features that you add in.
We're not this is that's something else. When all you're doing is building the first hardware that works, that does its thing, you don't need to do any of that. Way less. Like all you need to do, the biggest goal, the hurdle, and the reason why we have to define milestones is make a device that has a ternary transistor communicate with a full computer system and work
Yeah.
the whole way. So a
In
ternary
this case,
transistor that communicates with a CPU, that is able to direct a motherboard, and gain memory from memory. What you could also do is
yeah,
so
in this case, the computer does something like what an 8085, 8086 Intel chip would have. It's very simplistic. You just run simple operations.
Super simplistic. Yeah,
Yeah.
and who knows, down the line what we may realize is that we are able to, like, you're not gonna be able to see. I mean, what you could do, the more that you bend a knee to binary, the more that you decrease your efficiency and you decrease how great the system looks. So technically, it seems like you could put a ternary CPU inside of on top of a binary motherboard with binary memory, and it would just communicate less efficiently, but it would at least show a proof of concept that the transistors inside of the CPU work. So you could also take baby steps in that direction, just making sure the CPU operates and stuff like that.
Yeah.
With
Um.
that said, fully funded, I don't see why we wouldn't be able to get to that point in 18 months. It takes 18 months to perfect the ISA and to create the designs and the relationships needed necessary to build this. And then 18 months after that to perform the production of it and to build it. And by 2029, well, 18 months, by 20, before 2030, I would want Tern kit before 2020. Let's see, where is so these are the goals I'd love to have. Is turnkey is fully functioning. It's a madhouse. March 24th to March 25th. It's actually very fun. The hardware simulators in there, the IDEs in there. It's just like it's a workhorse, and it needs turnkey in order to flourish. Then from April to October 2026, we smack together a rudimentary Tern kit that does what it needs to do. In this time frame, we're also finalizing a transistor, and who knows how Tern kit works. It could work with binary components, or it could work entirely on a new ternary kit. And obviously, the goal at the end of this would make sure that it's a fully functioning ternary computer. And then at the end of the day, you get Cyrus, which is the microprocessor that is ternary, but it's also extremely small. It's the actual size of a CPU. Turnkit, the CPU could be enormous, and all the components could be. It's a Frankenstein computer, Turnkit.
Yeah.
But Cyrus is a clean CPU that uses ternary, that's able to go to market. Maybe not. I mean, that's a high goal, but really, we just want to be able to sell this to the U.S. military for cybersecurity. Imagine you make these giant data set like servers that are just cold storage for very sensitive information, like financial information or uh, personal health information.
Yeah.
You store all of that in ternary signals. Now all of a sudden it's much higher density, so you don't need as much space, and it's very. How are you going to hack into that?
Yeah. You need to. So this is more of an NSA thing.
What's that?
NSA.
Sure. This is at the end of the day, it's an engineering thing. It's an
Yeah.
engineering feat that needs to be accomplished, but also a business feat on top of that, because it's 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 clear that the engineering isn't the main issue. It ties very closely with the fact that people don't know how to enter the market with this idea, because it is a very disruptive technology. But you don't disrupt the markets by being disruptive. You disrupt the markets by intelligently entering with something that's disruptive and then placing it somewhere where it can make some noise. All right, that's the first podcast. Thanks, Ashutosh. Let's hop over to Scrum. I'll see you there.
Okay.